Hello, everybody, and welcome to the Navigation Challenge Q&A panel. We have the great opportunity to welcome some great organizers for these different challenges. So first, we're going to begin with just some introductions by them. So why don't we start with Shivansh, representing Multion. You just give a quick review of your background and yeah.
Yeah, hey, I'm Shivansh Patel. I'll be joining UIUC CS PhD this fall. I was the challenge lead for Multion, where we had a task where the agent had to navigate to multiple objects in a row, in a sequence. And this is very closely related to the navigation problems and memory, where the agent has to come back to things it has seen. So, yeah.
Great. Can we next go to Chengshu?
Hi everyone, my name is Chengshu Eric Lee. I am a PhD student at Stanford Vision and Learning Lab. I am one of the co-organizers for the iGibson Challenge 2021. In this year, we tackle interactive navigation and social navigation in which the environment that the agent is in is dynamic.
Great. Next is Matt.
Hello, I'm Matt. I work at the Allen Institute for AI on the prior team, and I'm also at UW. So I'm representing AI2 Thor and the RoboThor Object Nav Challenge.
Fantastic. Oleksandr?
Hello, my name is Oleksandr Maksymets. I'm a research engineer in Facebook research, working on habitat and embodied AI research in FAIR. And today I'm going to represent Habitat team and the Object Nav and Point Nav version 2 tasks that we proposed. Thanks.
Awesome. And then last but not least, Jacob.
Hi, everybody. I'm Jacob. I'm a PhD student at Oregon State University, and today I'm representing the R-Cross-R Habitat Challenge, which is a vision and language navigation task. And we want to give our agents natural language instructions, and they can follow those paths.
Cool. So we're going to start with a wonderfully controversial, perhaps, or aggressive question. So it's sort of two different questions that came in through the Slack. So first, navigation seems like a relatively easy problem. Why isn't it solved? And then also, it seems from the DDPPO paper that navigation has been solved already with greater than 90% SPL and greater than 95% success. Why do we care about navigation? And so I'll open the floor to everybody.
I think models tend to be able to pretty much solve tasks or navigation tasks in environments they've seen and trained on. Generalizing to different unseen rooms and different unseen houses is still quite difficult. And I think a lot of this work is being done right now just to try and get that to work better. But I think that's one of the key challenges still.
And a lot of the past success in navigation seems to be on this clean and static environments in which the robot isn't really interact within the environment. And it has, in the previous habitat challenge, it's assumed that localization is perfect, but this year obviously changed. I think there are certain assumptions that we are making when we said that we have achieved over 95% success rate there. And finally, we don't forget this is there's still the sim-to-real gap. So when you deploy the policy training simulation, there are some gaps in dynamics on the floor or the carpet, and there's a bunch of stuff that are not modeled very well in simulation.
To add to that, DDPPO is trained on the task of point nav, which is a simpler task as compared to what we want to see in real world, something closer to object nav or instruction following.
Okay, cool. I'm going to jump onto that, what Chengshu had mentioned, sort of we don't model a lot of things correctly, potentially, right? We have the sim to real gap. And so I guess one of the questions that sort of comes out of that is, how important, or what are the steps we really need to take to narrow the sim to real gap? Is the lack of high fidelity visual observations the issue? Do we need better physics simulations? Do we need to actually explicitly model the difference between hardwood floors and carpets, or is there some other approach we could take? And I guess, I'll start with you, Eric, if you brought it up. So
Sure, of course. I think I think we do not need to simulate the exact dynamics because that's extremely hard. And also, even if we can do that, it's going to make the simulation extremely slow, which is very unfriendly for RL. Therefore, I kind of agree with what Dhruv said on the Slack that some of the more control side of things can be tuned on the lower level controller level, essentially. When you're conducting real world experiments, you can do some tuning from a limited sets of real world experience rather than hoping you could really do domain randomization perfectly in simulation. So there are definitely a lot of work in domain adaptation and SysID, for not just real robots, right, but also for those kind of lag robots, which is even harder for sim2real. So I still think there's a bit of adaptation you need to do eventually, no matter how accurate the simulation was.
So I know within the, so talking about adaptation within the RoboThor environment, there was some push to be able to actually, do some training and testing and whatnot on actual rooms, right, that are very similar. And I think Habitat did some similar work. So you could talk a little bit more about that. I know a lot of these plans were stymied because of COVID, but is the sort of next goal that we actually, test our models on actual environments that have been trained in real ones?
I think for navigation tests, at least, it's surprisingly not as bad as you'd expect from sim to real, at least if you match like the environments and do these type of things and even have domain randomizations. But for interaction, I think it's still wildly difficult to even simulate that type of stuff and especially match that in reality, which is even in line with like interactive navigation and stuff like this. It's hard to do that and match what you have in simulation with reality there.
Yeah, I wanted to add that, we have a paper that is comparing a sim to real transfer. And as Matt said, it's not as bad as you would expect, as well as for this year, we had point now version 2 challenge, especially for answering this question. What will happen if we'll have more realistic noise on actuation and on sensors, RGBD sensors and so on. And I'm really surprised that with 2 years, we get close to where we can replace odometry with visual odometry. And that can bring you to the space where you don't care much about slippery of the floor as soon as you can localize your robot well, right? So you definitely want to train it with a good, even possibly more significant noise what you will have in reality. But if your visual transfer is acceptable, then possibly you can leverage your odometry and localization that you trained in simulation.
Cool. So maybe changing gears a tiny bit. It seems that a lot of the challenge submissions, sort of outside of maybe room to room, don't use much imitation learning. And so I first want to ask, in room to room, why is imitation learning important? And then sort of open it up to everybody else. Why don't you use imitation learning? What's going on here?
Yeah, it's an interesting observation. In the R-Cross-R challenge, we're using imitation learning for one, because the sample efficiency. When doing straight reinforcement learning, these agents need to see a lot of steps of experience before they can learn to ground language and vision together in order to accomplish these tasks. Whereas if we can use straight imitation learning, say behavior cloning, we can use these high quality data samples from our data set. So that is a benefit there.
I guess along those lines, do you think that you'll be able to use pure RL methods for RXR, or is it, imitation is the only way?
Yeah, we definitely want to move towards reinforcement learning because imitation learning can have some hindrances to it. For example, an agent is not able to learn the consequences of their own actions. Even when you're training with dataset aggregation type methods, Dagger, the agent is always being supervised with what an oracle would do at that exact given time step. Whereas in reinforcement learning, an agent can take a sequence of actions and figure out what the result was from taking that long sequence.
I want to comment on imitation learning as well, because with Object Nav Track this year, we have interesting entry from Habitat on Web team, which is actually train their solution using imitation learning. But the difference is that if you take Object Nav, your agent should go where the particular object of particular class. And usually you don't know it because it's unseen scene. And that means that it should be some exploration. If you just take a sequence that will actually be shortest path to the goal, your agent will overfit to existing trajectories a lot and will not learn to explore. But what Habitat on Web participants did, they actually captured the human performance with exploration phase and then use imitation learning for these sequences. And with a short amount of these sequences, like several thousands, they were able to reach not the best performance, but still reasonable. So I think it can be kind of connected with some other approaches and get better results. But this is interesting observation that it can help.
We've seen similar patterns in the VLN space where imitation learning can be combined with reinforcement learning and ideally seeking to get the best of both worlds.
Just to add to that, initially I thought it's easy to provide imitation learning data for navigation because you have the ground truth, right? Like you can compute the shortest path. There's an analytical solution. Then I realized, I think it was mentioned, there's a good point that when the agent is initially in the scene, it has less information, right? Like it doesn't know where the goal is. So there is this exploration phase. And I'm wondering, maybe one way to imitate is let a real human to provide demonstration in a virtual environment where the real human also doesn't know where the goal is, need to find the door or find the object or the exit. I think that would be interesting. Although the challenge there is that I think human demonstration is very, very noisy and suboptimal. So how to train a policy based on that is another challenge of itself, I think.
Well, so I think still on that sort of Dagger sort of, I guess, mindset, it seems like a decent number of people sort of initialize with, or a reasonable strategy might be to initialize with Dagger and then sort of gradually move to PPO, right? You'd hope that kind of get the best of both worlds. Have you had any experiences with that or these sort of warm start approaches for imitation learning and moving to PPO? I guess this is a totally new ground. No one has tried this within the space of navigation. This is going to be our next paper using DDPPO and Dagger together. Cool. So yeah, one question we got in the chat just really recently. So there seems to be a big disconnect between the robotics and navigation communities. You know, robotics tends to operate within the same environment for a very long time. In our communities, we sort of tackle each test environment brand new every time, right? You know, will methods developed for this short-term sort of instant case have uses in the sort of long-term environment that I guess Multion is sort of getting towards? Or, you know, are we valuing the wrong things? You know, if we have to see the environment new every time, then maybe the advantages of maps aren't really quite as apparent. Any thoughts?
Yeah, I think like even if we have, even if the robot operates in the same environment for the first time, it has to, when we keep it into a new environment for the first time, it has to do the task at least once. So always the bottleneck would be the first time the agent does a task in a new environment. So it is not that bad because we are still trying to nudge the bottleneck rather than trying to solve the whole task.
Yeah, I think it's an important question because my feeling is that it's something that is like actually different from how we expect to have intelligent assistants in our house to work. Because like you don't expect them that they should work perfectly in unseen houses. You just initiated them. You are okay with the mapping phase, right? And then if it works better. So it's a little bit less realistic, but I think intent was like that. If you can learn something that can generalize to unseen environment, definitely there is no way that is overfitted to existing environment, and that's only just some subset of features are important that is not kind of generalizing well. So I think we should as a community think about the task where you perform a set of things in the same environment, but again, you don't have luxury to train in environment that you are going to be deployed usually. So this is not going to happen. It can be a phase of your evaluation that you have like pre-exploration phase or something like that before.
It could be an interesting challenge to try to close the gap and have a SLAM system, for example, learned or traditional, where the challenge is, can you map the environment well enough that you can transform the object nav problem to the point nav problem to known locations? And like that, it seems like a well opposed problem. And I know there's a semantic SLAM in the next session, which maybe they have something to say about that. But it does seem like, what we do now is a useful first step towards that. But if we want to follow the speculation in the question and see that that's actually a problem that the community could tackle.
Yeah, I like this idea. Yeah, and another possible view on this can be, if you have an episode in one scene, can we just evaluate it that you still have a memory across this episode and you expect it to perform on the last episode better than on the first set of? Is your model improving with operating in the same scene? This can be also interesting behavior and challenge to see how good our models are in that.
Yeah, I definitely agree with what is said above. And just to add to one interesting note, last year we actually did this experiment with the iGibson challenge last year, where there's the sim to real part, right? So what we did is we rent a real apartment, and then we take a Matterport scanner, we scan it and put in iGibson, so people can train in that apartment, and then just to handle the sim to real part, not generalize to new apartment kind of generalization. But that's kind of interesting. So maybe that's something we could do in the future when we buy a new home robot. We first scan our homes, right? Currently we have mobile phones that can do that. We upload it to whoever who produced the robots, and actually, let the robot and overfit to that scene, and then ship it to your home and do a bit of tuning in the real. And maybe that works. Maybe that's a new avenue that we can try. I don't know.
I think there's a slight limitation to that approach. So suppose we're able to completely map somebody's home or environment. We send them their robot and they do home renovations. There's some sort of dynamics that change about their environment. That's where we go back to this gold standard of how well can a robot do in a novel environment. And we can use that to be able to guide progress on when an agent is encountering something novel, something dynamic, new in this environment.
Great, cool. So in the live Q&A that we had before with the speakers, Chelsea Finn noted that we were basically throwing away all of our data after every project, right? And this isn't quite as true maybe for the embodied space, because I mean you're not throwing away the evaluator, and it's at least we're not doing that, or we're not throwing away the simulator, so at least we're not doing that. But at the same time, I think there's a pretty clear parallel in that people will train their model, their brand new great mapping model in one environment, and then claim victory and then move on, right? And so what really seems to be missing is that we don't have any sort of joint training or evaluation across all these different tasks and environment, despite the fact that only speaking for myself, I mean, we put a decent amount of effort into making sure that the actions and cameras and everything was relatively the same between all these different environments, right? So, what is missing? Why don't people train and evaluate their models across the spectrum? Why doesn't somebody train their model in Habitat and test it in iGibson?
at least from an implementer's perspective, I don't think there's really a compelling reason or much of an incentive to. This reminds me a lot of like the paper from about a decade ago on unbiased look at dataset bias, where you can easily tell an image is from AI2Thor, or it's from iThor, or it's from RoboThor, or it's from iGibson or Gibson or Matterport 3D. And these are really easy to do. And then once you try and train on iThor and evaluate on Gibson, this is not going to get great performance. And why report it if it's just going to be bad?
Yeah, I completely agree with that. And I also think that the overhead of trying it on different simulator is a lot harder than, for example, in the computer vision community, try on different data set where you can just download different data set and try the models. I think right here is, I think we should do that. It's just that I felt like people, like there's different, like people need to learn to use different simulator in order to do a good job of cross-platform evaluation. I think something that we can still further work on in the future. I think we should move towards that.
Yeah, recently it was a part of the project when we tried to have the same model like learned in one simulator and evaluated in another. And I think there was a case before as well. So usually there is, yeah, distribution change a lot. So this is a main reason, right? You have a simulator, even like when you hide or like some little parameters, floor height, there was a difference in Gibson and Habitat, even for the same scenes, there was this difference that incorporated like loss in performance in the end of the day. So it's different. I think maybe we should work on some protocol. Like, okay, it's hard to set up the environment if you train in one environment and another and connect it. Maybe you can collect some like sequence of, as we talked about imitation learning, some data set that will be as simple as a vision, just images and some information that will give an option for you to fine tune your solution and get your model from one simulator be acceptable for another, something like this. And we have definitely like projects that do more of this cross simulation submissions to understand it better. But that will be valuable because, as I mentioned, for example, for object nav in AI2Thor, we would be happy to participate, but categories are different. We need detector for this new simulator trained. And if this will be answered, like detector is presented, so we can just abstract in terms of categories and maybe some mask where there's object, it will be easier for us to participate. Yeah, something like some additional artifacts that will help transferring one sim to another, that will be amazing.
Luca, can I follow up with a question at this point?
Go ahead. Yeah.
By the way, thank you all for your answers. I was listening to you folks on the live stream, and I thought I'd ask this question. So there's an interesting documentary on Netflix about black holes, and they cover one of the projects called the Event Horizon Telescope Project, which is an international collaboration between multiple teams. I think it's like 20 different countries, and it's over a decade-long project where they actually had to go to. The goal was to create the first photograph of a black hole. In order to do that, you need an Earth-sized telescope. You cannot construct an Earth-sized telescope, so you go cover the hemisphere with multiple telescopes and you try to solve the sparse reconstruction problem. The interesting bit to me was watching the coordination between multiple research groups, multiple countries, multiple funding agencies, and ultimately they wrote, you had to establish sites at multiple countries, you had to collect data, you had to work together, and you had to solve all these socio-political problems where you want to make sure everybody's heard, you reach decisions by consensus, you write a common paper, you make sure everybody's on the same page, even though of course we're all humans and we have our own interests and various dynamics going on. So my question to you folks is, given the fact that we're just discussing training in one simulation, testing in another simulation, what is the EHT equivalent for embodied AI? You each represent a different team with its own interests and dynamics at play. what's that grand goal where we can leverage the unique skills and strengths of everything that you bring to the table? And we can hear from anyone on the panel.
So for real world deployment, especially in things like RoboThor, I think it's much more necessary to be able to collaborate with other groups who don't have access to such resources. But for simulation, I don't necessarily think it's that difficult to, I guess, build your own simulator or even leverage open source ones and build your own tasks with them, which kind of leads to this having like 15 different standards for how these tasks should be done.
I think there's a question of how we want to align ourselves. One way is we could align ourselves bottom up by saying, okay, we have this set of tasks. Let's each align ourselves, these different simulators with similar embodiments, similar definitions, so that we can transfer these agents. Or if we take the top-down approach, we can say, what is some task that we want to align a community around, and go that bottom down and say, what are these component tasks, and build from there and align ourselves towards a goal, and then build out our infrastructure together in pursuit of said goal.
Yeah, so I think adding on to what Matt said, there seems to be this, or maybe a need for some sort of standards body, right? Maybe we need to come together and really sort of formalize and figure out precisely what the goals as a community we're chasing after are, and how do we specify these tasks in a very precise way that makes this transfer sort of incredibly easy. So like, everybody needs to have an object detector trained in their environment type of deal. Yeah, I mean, this is of course a hard problem. And I think it's difficult to get past the fact that, we are a community and we're very collaborative, but, there's some competition going on, we're all sort of competing for the same ideas. And I think we need to potentially get past that. Let's not be afraid when we see another group's paper come on archive. We should be prepared and we know roughly what they're doing.
I like the idea of imagining a grand challenge for navigation, where I think someone called it the gold standard is dropping an agent into a new environment. When you go into a new home you've never been in before, you don't go, right? You explore safely, you learn to recognize objects, and then later you can say, oh, I need to get to the restroom, you know where it is. But then if that's blocked off while they're doing renovations, you know to change. And we could design the scope of a grand challenge, say like, here's looking at deploying a robot navigation stack on a new class of robot in a new kind of environment. And it would go from being a kidnapped robot, not knowing where it is, to a robot that could return you, a map and navigate to a known object very quickly, and then tell you, oh, by the way, that corridor you just sent me down is blocked off because they're renovating. And that general problem could be of great use, whether or not you're an indoor navigation researcher like me, whether you're focused more on responding to sound, whether you're focused more on being in an industrial environment. There's plenty of room for different researchers to tackle that. And if we could come up with that kind of grand challenge and good metrics, then individual challenge organizers and groups could instantiate within that and tackle the parts of the problem that were relevant. And then, might be like, well, I'm not really going to, I do want my own simulator because I've got this distinctive type of robot for this task that I'm doing, but I can fit within this scope and I'm tackling this part of the problem. That might be one way of trying to get that shared understanding that we're progressing without, eliminating healthy competition or eliminating the distinctiveness of each individual problem.
I guess I think we haven't completely formalized that idea, but I would be interested in opening it up and getting people's perspective on what your sort of internal grand goal is. Where do you want to see, or what is this all leading to, right? What's the point of navigation? It has to have some context. What do we want to have out of this?
Yeah, so I first wanted to answer a comment on Dhruv's question. So my feeling is that our teams are now finding the specialization, right? So we see some particular teams like Gibson, for example, focusing on obstacles during navigation, more dynamic navigation. That's very interesting, and low-level control that is close to robots. Different teams are focusing like still in discrete action space, but much harder task, long horizon. So we start getting our specialization, not like to go with one field with different simulators and just initiate our own task, but still in simulator is a part that everybody is reinventing. And I'm curious what will convince your team to join and say, this is our simulator, we are going to use everyone. It's like MIT license, everybody can fork and work with it and so on. And we are not going to, there is no like one person that can just ban your decision or something like this, but still we can kind of focus more on research goals instead of all do the same engineering process. So for this, I think first we can learn, come with lessons we learned. We have different challenges, some similar tasks previous year. What was the difference? Why one approach was popular in this challenge and another was approach popular in this challenge? Is actually the simulator difference was causing this, or like one simulation was harder, another was easier, and then still we can just come up to common understanding? Or we still need to have these different simulators to progress and not to be biased to one particular approach or one particular interpretation of the task. Yeah, coming from our Habitat team, we made our best to make a simulator fast, open source, MIT license, free to use, like not locked to particular vendor, and loading different data sets and scenes. And we are open to collaborate with teams that want to load their scenes in the simulator. We would be happy to see this.
Yeah, I also want.
Sorry, Oleksandr, can I just press? Luca's question was, what's your ideal task? What would you like to see being solved?
So it's a question for me. Yes, I think in terms of a little bit more complicated task, rearrangement task, like clean your room, this is something that is coming with the rearrangement paper. I think is great next task above navigation. In terms of navigation, that's a great question. I think even like for this rearrangement task, robots should navigate in the apartment safely, understanding where there is semantic context for the people, as well as like dynamic social navigation makes sense a lot. Like, and low level is also important. So I think as a community, we are tackling different pieces of that. And then we should start joining it into one like super hard navigation task, which will be great base for rearrangement task, because that's what you need. You need to place your robot in particular location to perform some interaction with environment, not hurt people, and do it in an effective way, not just with discrete actions which are not optimal in terms of time.
Sorry to interrupt you, Chengshu.
No.
Go ahead.
Oh, no. Sorry, I just want to also try to answer Drew's question and also Luca's question. For Drew's question, I think we definitely need a shared benchmark, like what Oleksandr said. I think it would be really great that we have an offline evaluation, like episode data set that have hundreds of thousands or millions of episodes that can be used across platforms. And ideally, these episodes are very diverse, in terms of RGB sensors in different scenes. I think we have reasonable number of large indoor scenes, right? I think we can do that. Dynamic, if we had to have dynamic agents and dynamic obstacle, that would be even better. But that's something that kind of people can compete, on a year-long basis, like ImageNet, for example. And I also feel like we need to have, maybe we can put our fund together and then create this real-world setup where we can, like before, right? Like you have this idea of everybody can submit their solutions and some people will test it for them. And I think that would be really, really awesome. To have something running so we know where's the gap to the real world. In terms of the golden standard, I think for navigation, again, I think diversity is very important. And then one step up will be rearrangement. I think even beyond rearrangement, there are still a lot of other extended object states that are not covered by simple pick and place, right? I think people still, like there are these variety of complexity in the household activities that are not just restricted to pose. For example, there's temperature, there's this the sliceness of an apple, or the dirtiness of a tower, etc., etc. I think that would be an even further level that we could potentially tackle.
Going back to what was said about like evaluating these on the real world with, say, RoboThor, I think one of the big things we found is that it's really hard to do this autonomously, like without a human in the loop. And then even just scaling this beyond one environment at a time is quite difficult. So you pretty much have to have someone there 24/7 to monitor these agents. And that's not really that great of a solution, at least in my opinion.
I guess, yeah, and especially as we move to a more like social navigation type settings, I guess, Jacob, would you have any ideas of how would we evaluate models in the real world when they have like language? Is this something you've ever thought about?
Yeah, I would say evaluating these such language navigation models in the real world, we can start with these static environments where we've already had a study by Peter Anderson et al. Where they did a sim to real transfer for vision and language navigation. We can create these physical spaces and map them into our simulators and use that as our transfer. And we have ways that we can do that evaluation, and we can specify those paths and compute alignments. I have one point to add about the gold standard idea of creating a task amongst everybody. I think that is a very interesting question, especially for this group, given that we each have organized these different challenges that are all focusing on a different sub area. I would like to add to it that how to specify a goal to an agent is an important question, regardless of the actual task that we try to accomplish. And that sort of human-robot interaction is something we should keep in mind as we push forward as a community. And I think that using natural language to interact between the human and the robot is something we need to continue to push forward on as we specify our tasks.
And I know Room to Room, correct me if I'm wrong, but has some multilingual components, but presumably that's also a huge issue. Could you expand on maybe a little bit more upon that? How do we get enough data to be able to actually have these assistants work in India or China or something like this?
Exactly. Yeah, we have a monolingual bias in a lot of our data sets to the English language, or even for that matter, the top 10 languages in the world. And since our systems rely so heavily on vast amounts of data, it's a very big problem when we want to deploy these agents for speakers of other languages that are not as prominent in the world. And so developing systems that apply to other languages is a start, and developing systems that apply to underrepresented languages is an even bigger challenge there, that we hope that Room Across Room can take a first step towards by saying, hey, this is a monolingual data set, and we are going to evaluate on all 3 languages here.
Oh, I have a question for Jacob. So how big is the monolingual bias? So if you have one language instruction in one language, then you can, and if you have a good language translator, then you can effectively say that you have language instructions for all the languages. So how big is the monolingual difference that is causing all the issues in moving from one language to another?
That's a really good question. Yeah, the quantifiable difference, I would have to point you to the R/R paper, where they go into details of trying to use translations. I would add to that people that speak different languages will convey their ideas differently, and possibly look at different ways of providing an instruction to a robot. And so while you could just directly convert a semantic of some instruction, you may have different characteristics of an instruction by different populations that speak different languages.
And Shivansh, do you have any perspectives on what a grand challenge would in general look like in the navigation setting, or just in general? What are we striving for?
For short term, I would say for navigation, I just want my robot to bring the cup of coffee without bumping into anything strange.
The coffee bias is real. Yeah, I know. Okay, great. So that was a very illuminating discussion. I think I'm gonna, unless anybody else has some more to add on that one, I'm gonna move into a little bit of a different, maybe more practical direction. So I think one thing that we've really realized, and Oleksandr sort of touched on this before, is that to be able to train these agents, big data in terms of variety is great, but even within sort of the same environment, you really need a lot of frames, right? And so simulation speed is sort of critical. And across these different environments, we've all used our own tricks to be able to speed them up. And so I guess I was wanting to hear sort of what your learnings are from that. What are the best ways to sort of improve simulation speed? And what are the big hangups?
Luca, is it a question for me? Kind of?
Yeah, for everybody, but let's start with you, sure.
Okay. Yeah, so in our team, usually we come up with simulate only what you need. So if you are simulating physics, you should simulate only physics around the robot if that's what's important and its focus of your training. If you simulating graphics, before moving to high fidelity and saying that high fidelity is very close to reality, we should evaluate how important is that. And depends on the task, but at least for point nav, it doesn't look that this high fidelity is as much important. It has this high importance for navigation, for example. But for something else, like when humans are interacting and with robot, maybe it's more important. Yeah, so mostly this sacrificing parts that are not important and focusing only on that shows improving performance of your agents.
Yeah, we've also found this to be useful as well in terms of just rendering what you need in AI2 Thor. We've recently had a few big speed ups just by doing that, and then not returning all the object metadata and stuff like this when you don't need it. I also really like this recent paper from Habitat, the team, and where it shares the memory of the simulators, or of the instances of the simulators at once. So you don't have to store different objects for each time you run the simulator. And this had pretty substantial improvements in terms of 10,000 frames per second or something like this. And I'd really like that in AI2 Thor, although it's quite hard, but I think that's a super promising approach.
Yeah, so I think that's when you're touching on this, it brings up this interesting tension, I think, between optimization versus generality or generalization, right? So I can't speak for this most recent paper, but generally, as you try to optimize your speed, your ability to add new features is sort of diminished, right? So if I have local physics, maybe I need a custom physics simulator, and then I won't get any of the nice rendering and things that come out of Unity. So I guess have anybody found that to be a problem? Have you built something for speed that you then realized wasn't flexible enough for something else you needed?
Definitely, what Matt just mentioned is batch rendering. This is a very powerful technique when you have one simulation that is actually looking as a number of environments towards for your training your model. So it's as we are not humans, we have agents. You can have one simulator that is generating multiple views for a number of your agents, but that it's giving you limitation that you cannot do different actions in random time in any of these environments. It should be synchronized in some way, for example, or at least like async, but then again, you don't have this control one-to-one between your agent and between the environment.
One other maybe obvious thing to mention is I think the big benefit you get from AI tutor is that you have this ability to simulate interactions really well, although you don't have this great speed up that you get from Habitat, which is one of the downsides there that is quite annoying.
And one thing that we, the iKitchen team encountered is that as we make our scenes fully interactive, we are dealing with hundreds of objects in the scene, not just one static mesh. And how to exactly scale this up without spending time that linearly grow with the number of objects, which is very challenging. And we've spent a lot of engineering efforts into that. And one thing that really echoed is exactly what Oleksandr said, that there's this object sleeping idea in physics simulator. So if the moving agent can only affect what is surrounding, then all the other objects should go to sleep. The same idea for rendering, like we can, for example, pre-allocated memory that have all the texture maps, and it's just easier to read them. And that will also give us quite a bit of speed up. But yeah.
One question there, how do you decide what to render? Because if you imagine throwing a ball across a room, maybe it hits this object that you didn't anticipate earlier that it was going to be interacted with.
Right. One thing we did, the trick is actually thanks to the physics simulator. So essentially, if they're forced wake up certain objects, we also know that we need to update their poses in the renderer. So we have this coupling.
Luca, can I add a follow-up?
Yeah, you came off, so I was wondering.
Yeah. So here's a way of thinking about simulators, and this is something that I think I'd presented to the Stanford folks in my talk, and I haven't publicly sort of talked about it elsewhere. But there are two ways of thinking about simulators. One is you could think that simulators are like data sets, that they're just the dynamic version of data sets, in which case there is no such thing as a universal data set. It is dependent on your task. And so depending on what problem you want to solve, maybe there will be multiple simulators and they will forever be around. And it means that your prediction for the future should say that as we have more tasks, we will have more simulators. And that's one possible pathway for the future. And the other way of thinking about simulators is that they are frameworks or libraries, or they're like platforms, and they're like PyTorch or TensorFlow. And when you take that view, it becomes pretty clear that the market is almost winner take all or top 2, 3 take all, right? The TensorFlow and the PyTorch and maybe one else will survive, and the Theanos and the cafes of the world will be thanked for their thought leadership and their contribution, but ultimately sort of sunset at some point. And the future there is that. Right now, it's not clear to me. Like right now, simulators are like the Schrodinger's simulator. They exist in both worlds. So maybe, in the spirit of falsifiability, we could get people on the panel to predict what do they think about this and where do they think future lies.
Perhaps a bit controversially, I think this is pretty much a winner-take-all situation, just because when you see someone start to use one simulator, they pretty much never change, and they find out that their tasks can, with enough effort, be transferred into this new simulator. Although that's not always the case with some of these simulators that currently only work for navigation, it probably will be at some point.
Any other thoughts here?
But can I just ask, like, so you're pointing at a universal simulator, right? There will be something that will satisfy everybody's need, but it feels like people want to solve many different kinds of problems. And like, do you think there's a universal data set?
No, but I think you can build on top of a simulator to do any other task that you want. I think you're seeing this with AI tutor with things like Alfred, where you have these vision and language tasks, or rearrangement, where these are vastly different tasks, but they're not exactly the same data set.
And how about when we have to do clothing, fluids, like fine-grained things? How about when someone wants to, study just sort of human-robot interaction, or something that's so fundamentally different that they find it's easier to start from somewhere else?
I could see this happening, like if you think of an outdoor simulation or a factory simulation where these aren't even in AI tutor, you're basically starting from scratch. You may have to do this, but at least for the tasks we're proposing and these sort of shared benchmarks, I don't necessarily see that happening as much.
Okay.
I do a lot of work. Our team has done several different simulators, and I do a lot of work looking at cross-simulator work at Google. And without going into total detail, like we've done everything from very simple, the grid worlds in testing, forget those. The very similar, car or bicycle models, dynamic model simulators, which are great for speed. And then we've had higher level physics simulators that we've used. They really aren't as useful for a lot of training, but when you get to integration tests on a robot and want to understand the implications of deploying software on the robot, they become more important. We have had people who had to do, grasping of soft objects, and they used finite element modeling. And the fourth one, my team has not used as much, is high fidelity visual simulation. So there's at least 4 different perspectives you can come at this, and they're not all compatible at the same time. All right, you can't really do FEM or high fidelity physics at the same time as having a very, very fast car model. And what I personally find is that if you were trying to develop an AI algorithm and you have to change your simulator, you'll just spin your wheels. And so it's really important to try to perfect a technique. But once a technique is perfected, and then I want to extend it to a new simulator or a new context, then it's more feasible. So I think that this model, I like the model of like the framework more than I like the the infinite number of data sets, because I think there's a few classes of high fidelity physics, high fidelity visuals, fast, or it really matches my robot. But you could have one framework that enabled you to do all of those different things and have those things talk to each other and say, well, I'm in here, but now I can easily go there. So I think that there's a role for that. But if I was a researcher starting a problem and I did a build versus buy assessment, which everyone should do, and there was no way to, like, for example, like say implement what I wanted, I could see why someone would start with a new one. I would first, I would look at Gibson and Habitat and AI Thor, and I would look at all of them first, though, because I think that a lot of the times people are just simply aren't aware of what already exists. And it's our job as a community to make people aware that you really can do this for many tasks.
Yeah, just to add to that, I think I'm leaning more towards the data set point of view, at least in the short term, because I do feel like, we look at a lot of comparison between different simulators, and I do see that people are different simulators are specializing and good at different tasks and have different capabilities. Some even have different underlying physics engine, right? Like Flax or Unity or PyBullet. They have different rendering mechanism. They have different assets management, for example. Is it buying from Unity store or is it downloading some OBJ files you bought from TurboSuite, for example? And I do think, at least in the near future, as we kind of this field of embodied AI flourish and so many people are tackling on different fronts, I still feel like we will end up with a very great diversity of tasks in the simulator in the near future, at least.
I know I'm not part of the panel. I just wanted to make a comment. I think it's important to also know that there are people behind these simulators, right? So every team brings in a new diversity or new angle towards doing things. And I like how the last 2 workshops and efforts by a lot of leaders on this group, I see it from the outside. And I enjoy the fact that there are these papers written at every frequent checkpoints where all of these leaders kind of come together and do a conversation, and they write a tech report or a white paper on rearrangement or evaluation of embodied agents or so on. I do feel we're in that from a robotics perspective, and when I talk to people in the robotics side of things, people still feel that our field is slightly new and still evolving. So if we form like a single thread and work together as one big group, there is possibility that we'll not be able to come up with these cool alternate takes at doing things. And that's probably why groups at different universities work separately and not as like one big oligarchy, or a monopoly of sorts. And this oligarchy at this stage, or like this few groups trying to do different things and new things, is pretty interesting but I'm not particularly involved with one group per se, but I see it from the outside and love that people are bringing in new factors and new things which they wouldn't probably be able to work on if all of them were a slow-moving, bulky group, I guess. So I'm just bringing in the practical angle that the people behind these simulators, and it could be a data set or a framework, but I think they're also people. So that angle comes kind of interesting to me from an academic outsider perspective.
Cool. So we have a relatively short amount of time left. So before I ask everybody to just sort of summarize your takeaways, maybe I'll quickly ask one last question. You can sort of put a one-sentence answer to it. So over the last couple of years, it seems we've been sort of going back and forth between sort of adding in a bunch of inductive biases to our models, like mapping and things, and then moving towards end-to-end methods. Like now we can do auxiliary tasks and we don't need mapping. And it sort of like, goes back and forth. Where do you see this going, just quickly, in the next couple of years and eventually?
I could start. So one thing that introducing these inductive biases gives us is a way to overcome some data sparsity. I think that once we can scale up our data sets and train our agents on them, we will require less of these sorts of things. And one thing that is encouraging here is that we see blind agents, and they're doing that with these general architectures. And so if we're able to see some of these things emerge in our general methods, we can make them more impactful as we scale up our data.
Cool. I'm going to take that as the summary for everybody. So I'll go through everybody in sort of the reverse order, and you can just give the sort of high-level takeaway that you'd like the audience to go away with. So in reverse order, Jacob.
Okay. I think it's really cool that we were able to get this panel together from people with different perspectives and trying to accomplish different navigation tasks. And so one takeaway that I would like to supply from the R-cross-R perspective is that navigation can be more than specifying a point to go to, and interacting with a human via natural language. We can specify these continuous paths through environments. And if we can encode our goals via natural language, we can make our agents more accessible to the general population as we look to deploying these agents in the real world.
Cool. Oleksandr?
Yeah, so for me, a takeaway is like from this Q&A session is that we should explore more like sim-to-sim transferring and the overall like diversify more in different aspects and learn from a task where the task is similar in simulations, what the difference of simulations can bring to the task and to the approach, something like this. This is my takeaway.
Cool, Matt.
I think the biggest takeaway is that I'm glad there's a lot of collaboration here between like a lot of different organizations and a lot of people coming at this from different angles, and just the success of simulation, even in the past few years, has been pretty remarkable, to say the least. And I think that's looking to continue.
Cool. Chengshu.
Yes, I echo with a lot of the previous speakers, and I think it's really great that we can gather together among so many institutions and synchronize on the task setup and describe what is the simulation difference, why the difference, and reality is just not a simulator, for example. Then what is the difference compared to that? And I think we should really continue doing that, and I'm really glad to be part of this panel. A quick takeaway for the Gibson challenge this year, I think what we learned is that for navigation in dynamic environment, which is a little bit less underexplored compared to point nav, for example, it's still an unsolved problem, and it's a multi-objective optimization problem, because you want to achieve the goal with the minimal time, the shortest path, but at the same time you don't want to destroy the scene or be too close to the pedestrians or even hit them, for example. So how to develop solutions and even metrics to measure success is still an ongoing work. That's it.
Great. And last but not least, Shivansh.
Yeah. From my side, the conclusion is not explicitly came up in the discussion, but I think we all are tackling very different parts of the problem, but eventually we have a similar vision and similar goals that we want to deploy robots in the real world. So we should not lose vision of it, because eventually everyone keep asking, hey, what we want to do? This is what we want to do. And right now we are solving small parts.
Awesome. Thank you so much for being here today. It was fantastic to have you. Next, we have the interactive challenge presentation videos and then at 5 p.m. we have the interactive challenge Q&A panel. Again, thank you so much.